also presented. I am an experimental researcher on marine confinement, and from my grad student, and I moved to Tokyo Tech in 1995, and I got intimate with Mr. Oyama, who is private sector researcher. He calculated interesting isotope distribution, which had been measured by Professor Kamoto. In those days, Professor Kamoto is the leader of the cold fusion in Japan. And he quoted his strange profile in his original book, shown here. And this is the isotope profile in the electrode. And most of cases, isotope ratio is at natural level. But in one case, lithium-6 density drop as natural abundance. And it's very hard to interpret what isotope enrichment occurred in the electrode. So I would like to show this result, taking this opportunity. And this result was presented third conference. And Professor Odawa is an expert on elemental analysis. And Mr. Oyama asked him, because he's a friend of him, and Professor Odawa said there is no mistake. You have definite confidence on this result. So this is very interesting profile. Anyway, now I move on to my topic. This is transmesh used by Norman's group, and we use this very elaborated structure, multi-layer, and this is expensive setup, and this multi-layer is placed here, and usually gas evaporated from both sides. And this is the result. When hydrogen gas is permeated, there is no transmission. In contrast, when deuterium gas is evaporated, although the ratio variation somewhat different, but reports usability of the phenomena is evident. They present this paper in 2002, and we fusion group know the paper, and I asked him to give a seminar talk at Tokyo Tech, and then we visited his facility and analyzed sample brought by him by laser ablation ICP mass analysis in 2004 using these equipment. And sample is placed here, and the sample averaged by using laser pulse and greater diameter this, and sample gets at this level. And other yes, introduced into ISP mass analyzer. And this example result here in the middle along this line, and the distribution across the long down here. And Professor Hirata estimated the concentration around 2.2 ppm. And Martin counts from steel, and it always makes in at the same level during multi-level volume probably by being reported by your umbrella. And in 2010, she was a visiting professor from the Institute of Physical Chemical Research. So I asked her to analyze the same sample using thermoflight mass analyzer using femtosecond imaging. And this is a result of the mass spectrum. These elements could be observed, and causing isotope peaks and saving. And only one peak appears here. Note that there is no other peak that saving combined only one or two or three on this side. And positive oxide and positive fluoride is clear evidence of the presence of potassium. So we began the replication experiment in 2011, and the fixer is put a film controlled by sputtering duration. An example of the film of 10 by 200 watt and 15 minutes with breaking sputtering. This is the data to estimate the filming speed. While this slope we estimate required sputtering time or duration mark here. Note that this argon gas was absorbed in an oxide target, it was not easy to keep filling condition during short 200 watt string period. Anyway, we made by sputtering. And this expense setup we brought. Every vacuum component newly purchased because we expose impurities. And this is chamber of 20 liters. And this is the flange here for install multi-film there. Pump of all three are used, the motor pump and scroll pump. Firstly, we check the required number of calculated layer achieved setting the transmutation. I wondered why such a very elaborate structure required for transformation. And there was a practical reason to check because it's very tiresome to plot these layers by exchanging the splitting target. So this is example of the pumping temperature pressure by pumping. At 70 degrees C, the drop is very small, so we raise the temperature. And in this case, up to 140. Anyway, by variation of the curve, we estimate effective volume at 1 atom. And this is example photo of the mounted there from after termination. This concaves indicate that this side is the front side. And apple at the corner indicate the front side because before the termination, it's very hard to distinguish front side or inside. And we made one mistake. And by a result, we confirmed that even the much less side, but the pumping side, the transformation occurs. And some couple is right here to monitor the temperature. And element analysis made using two diagnostic wide energy viscosity and same content detector who with nitrogen was used, so energy was down to 10 volt. And another one, carbon flight secondary ion mass gateway, mass reduction down to 3 decimal places. But there is actual program, practical program for difficulty automatic analysis on non-flight sense data. The mass corresponds to the Chern number, slightly different in every measurement. Although the flight time should be calibrated around the specified mass, as a difference about 0.03 often exists. This example looks easy to result almost of the peak, but in this case, about 0.153 the result. And these red numbers indicate numerical peaks considering the symmetry of the count, not maximum value. So there are up to 800 about this line to obtain and we store data other here 300. Anyway, many data. So therefore, our first way to check contamination, once they feel formation or using the plating process. So we analyze pure protein, pure and free of cell layer film. Then using gas with permeates. First, we also checked normal sample and then the test of the number of calcium oxide layers. This appeared to be found no permeation, so no impurity peaks. And the layer film, no permeation. Also no impurity peaks. This is my product. And this is a sample provided by Mambra. In both EDX and Tom's seems clear present peaks of observed. And
you have 2 minutes.
Yeah, this is a 5-layer film. Is I define the floating up to sometimes 3. For this, if I could get not much, so the peak is a little bit more. Anyway, by changing the number layer, it can define the floating in both diagnostics. And this is every permit case, we observe the presence of persistent sodium here. Note that sediment also diffuse into the first plasma layer by increasing the film temperature. And by mistake, one case fixed the film in backside, so that downside, even that case, the person was detected. And while the induction side, they accumulate in the first calcium layer, pressure temperature higher than 120. And this is the index result. In backside pumping, we detect just above background level. And so the pressure identification, the count but not highs. These are count some in the range of 0.1. So this is the background level, and this includes background level, but beyond anyway, background level, another sample is higher. And we newly identify cell 140, presumably by this transmutation. And
I'm afraid that we're not going to have
so,
time for questions if you don't finish shortly.
and so you also identify what is here. I skip here. And these are magic numbers. And T1 to white will also identify. And for gamma ray, we detect flashed spatial radiation transmitter surrounded with red blobs except the one side. And by iteration mode, when permeation goes above the one level detected. And although we tried to find other transmission to nuclei with magic number by adding other elements, we failed. But we tried only once in most cases. So this is my conclusion. When one calcium cell exists in a plugin film, nuclear transmission occurs to nucleus with magic number as shown below, but not only upstream side but also downstream side with intermediate permeation. From Thompson's count, characteristic X-ray intensity and natural balance use the isotopes that transmission were easily going above order. Gamma ray above background level were never detected. Thank you.
Thank you very much. We have time for 2 questions only. Any questions? Konrad?
I would like to ask you about statistical uncertainties, because the number of counts you have measured was very low. So it's a question, is statistically significant or not?
Yeah, in this case, it's significant because it's also considering the natural abundance.
This is
But in the case of this is not enough.
there are not
Counts.
numbers, there are not counts.
Yeah, this
There's not counts. Yeah. So this is a question: what is the, because if you have 3 standard deviation, where is that? Okay, so it's something what can be happening. So and this. Yeah. Okay. So this
Yeah.
question: what is the statistical uncertainty?
unbelievable for this. Must analyze
The
but
numbers you presented here, there are counts.
count, yeah.
Count. So you have, in the case of this enhancement here, 159 counts compared to 36.
Yes.
Yeah, this, and what is the background is 36. Yeah, this at the edge of the statistical uncertainty, obviously.
Yeah, in this case, but for other transmission, this count is very high. So we could not exclude this count at this level. And we also define the presence of the element by X-ray peaks here. So
This either X figure is not,
yeah,
this is something else, so it is a very nice method to see, to observe what is the bulk and contamination. But the X measure, only the surface, not the bulk. If
Yeah.
you have contamination with the bulk, some of them can go to the surface, and therefore you can see on the surface artificially increased amount of some elements. Okay, so LX is something nice, but the final conclusion should be made from the bulk, or about the bulk, not on the surface. Okay.
yeah.
This might be.
But we only observed these 7 peaks with permeate sample, not for other sample. So I don't think it's diffusion of impurity from outside.
Okay, we don't have time for other questions. So thank you very much for the presenter.
Thank you.